Assalamu alaikum students, welcome to our first lecture of class 10. In this lecture we will study about simple harmonic motion and the mass attached to a string. So just before going into the topic, what is important here to understand that what is vibration. So a body is said to be in vibration if it moves back and forth or to and fro from a point. Like let's say you can see a picture here, this is a spring which is and a mass is attached with a spring. So if you exert some force on a mass, so if this mass comes downward, then this spring comes downward and then it again goes upward. So this is known as the movement known as back and forth, or you can say it as to and fro about a specific point. Now the vibration is also known as an oscillation, and here we will discuss a special kind of a vibratory, or you can say an oscillatory motion. It is known as simple harmonic motion, which is also known as SHM. So what is simple harmonic motion? It is basically a special type of periodic motion. With periodic means like it follows some specific time periods where the restoring force, there is a force known as the restoring force. We will discuss about the restoring force later on. So the restoring force on the moving object, which is directly proportional to and opposite of the object's displacement vector. Like when your object is moves, so this moving object is directly proportional, but it is opposite in direction. So we have some specific examples of simple harmonic motion, such as motion of a mass attached to a spring. Like if you hang some mass, like you can see an example here, there's a mass which is attached with a spring. Or motion of a ball placed in a bowl. Like let's say if you have an oval shape or circular shape bowl, and if you have a ball over there, and if you move the ball over that bowl, there's a specific motion over there. So this is also an example of simple harmonic motion. And motion of a bob attached to a spring. Like you can also see some examples here, like a very famous and a very everyday life example is a boy on a swing. Like you can see a boy is waving on a swing, so it moves about a point, and from that point it goes above, and then it goes upward and downward. Similarly, there's a tuning fork. So the vibration of a tuning fork is also a simple harmonic motion because it is around that a specific point. So these are some specific examples of simple harmonic motion. So today we will discuss about the motion of the mass attached to a spring. So it is one of the simplest type of oscillatory motion, and it is, you can see, a horizontal frictionless surface in which there is a mass which is attached with a string along the horizontal surface. So let's say this mass is m, and it has this mass can be like we can exert the force on the mass. So when we exert some force on the mass, so you can see that our spring can be stretched as well, and our string can be compressed as well. So just before stretching and compressing, there is a position known as a mean position. So we say that mean position is O, like this is our mean position, and it is known as a relaxed mode, like there's no stretching, no compression. But when we stretch that one, then it is an extended mode, and when we compress our spring, then it is known as a compressed mode. So now let's say if you can look at this picture, so if the spring is stretched or compressed through a small displacement x, like our string is stretched or compressed and it covers a small displacement which is known as x from its mean position. Like you can see here, this is our mean position, it's O, and we are exerting some force on it, and due to this force our spring is stretched and it covers some displacement x. So what happens? It exerts a force F on mass m. Now there is a law known as a Hoax law, and according to this law, this force that we exert on the mass is directly proportional to the change in the length of the string. Definitely the spring length has been changed, so this length that it has covered is known as x, and according to that law, this force is equal to minus k times by x. X is basically the displacement that we have discussed earlier, F is here the force, and K is known as a spring constant. So this spring constant, so K is basically known as a spring constant, and this spring constant K is a measure of stiffness of a spring. So a stiff spring, like if you have a spring which is stiff, it has a larger value of K, and if you have a soft spring, then it has a smaller value of K. So as we have discussed so far that F is equal to minus K times by X, so just by rearranging this equation, K would be equal to minus F over X, and we have studied, we know the second law of motion, that force is equal to mass times by acceleration. So just substituting the value of force here, so it would be K equals minus ma over x. So just by rearranging this equation, we can derive the equation for acceleration. So acceleration is basically equals to minus K over m into x. So just remember one thing, x is basically the change in the length of a spring, K is a spring constant, m is the mass, and a is basically the acceleration. So now this minus K over m is basically known as is a constant. So we can remove this constant, and we can remove this constant with a direction of proportional, constant of proportional, and it is a is directly proportional to minus of x. So you can see here that acceleration of a mass which is attached to a spring, it is directly proportional. You can see a directly proportional sign here, directly proportional to its displacement from a mean position. So what we have done, we have just removed this equal sign and replace it with a sign of proportionality. Now one more important thing is there is you can see a negative sign here. So what this negative sign indicates? This negative sign indicates that the force exerted by a spring is always directed opposite to the displacement of the mass. Like let's say if your spring is stretched in the x direction, then force is always, you can see in this figure B, the force is always exerting in opposite direction. That's why we have a negative sign here as well, and we have a negative sign here as well. Okay, so the spring force, one important thing is that the spring force, it always act towards the mean position, and it is also known as a restoring force. Like we have discussed the restoring force in the definition of a simple harmonic motion. So that is basically this restoring force. So a restoring force, it always pushes or pulls the object performing oscillatory motion towards the mean position.